It's me. Hope everybody's doing well. I wanted to look at the next big unit that we're talking about in 115, which is solving systems of equations, which you know what they are already, but I'm going to give it a quick review of what you should already remember that we know how to do with this. If you remember what a system of equation is basically that we have some value of x and y that solve two equations at the same time. So I could do something like, if I add x and y, I will get 23, but if I subtract that same x and y from each other, I might get a 7, say. And that's the most basic system of equation problem that pretty much exists. A couple of things to point out. The coefficients are invisible, but that doesn't mean that they're not there. They are there, as we know, and that means that the coefficients are, every case of these is a 1. But we don't really need to list those because that's kind of like a high school thing to do, and we don't really need to worry about it in college, so I'm not going to use those here. Just the underlying understanding that there's a 1 there at all times. And this is a graphing solution that we're going to be working on, but for this particular problem I wouldn't probably do that. I would just go ahead and solve the way I see these normally, and that's going to be by adding the two lines together. And if I follow vertically, I should be able to keep these together. So x plus x will give me 2x. Y minus y cancels out, and that's the reason that we call this the elimination method, because we eliminated a variable by combining these two equations together, and I get 30 by adding 23 and 7. X therefore will equal 15. Alright, well, if x is equal to 15 and I put a 15 here, 15 plus 8 will give me 23, and then the check would be, does 15 minus 8 give me 7? And it does. 15 minus 8 gives me 7. So my solutions for this are x equals 15 and y is equal to 8. Now that's my bare bones system of equations problem. That's pretty much the way you've been trained to do these. But this one looks like it wants us to graph the solutions. Okay, so a quick overview of that. When you're having to graph a system of equations, you've got 3 possibilities of what might occur. The first occurrence, I'm going to draw, actually I don't need that, I'm going to draw freehand. I'm going to draw a really rudimentary grid here and go with the 3 possibilities here. The first possibility is the most common one, which is that when I have a linear equation going in that direction and another one going in that direction, they intersect at that location. Now whatever that hits at tells you that they both contain the same x and y coordinates, and because of that we call that a solution. So you have a solution when you've got a collision of lines, an intersection of lines. There's also other possibilities though. For example, if I'm just looking at this line here and I asked you what is the solution of the red line with this blue line here, well, evidently you can tell from the way I'm drawing these are meant to be parallel. And remember from what happened just prior, if 2 lines are parallel, that means they have the exact same slope. They will never intersect. Okay, in the case of this happening, they will never have a common x and y, so that you say they have no solutions. Okay, there's never going to be a situation where they meet, therefore that would be no solutions. Alright, the third option, and I'm going to use the blue line for this one. The third option would be what were to happen if I were to graph an equation and I were to graph another equation and it would end up being the exact same line. For example, this one. What would that be called? Okay, because we don't really know what to do with that. And if we did have that, that's a new possibility. We would say that it has infinite solutions, because every x and every y is common to both equations. They're basically equation mapping onto itself is what's happening here. So once again, you've got one solution, you've got no solutions, or you've got infinite solutions. Those are your 3 possibilities, so keep that in mind. Now for this problem set that we're going to have here, I didn't open this before because I want to be surprised. I want to see it the way you're going to see it. So I'm going to start this video lesson Remember, video lessons count in the gradebook, so do the video lessons if nothing else. Let's start. Okay, so they want us to graph. This is one of the 3 methods of solving. We just did the graphing method, and I'm going to click through. You get the video. It might be a good idea to look at the video in these cases because it might supplement the knowledge that you have. But if you think you're strong enough to keep going, then you proceed. All right, so we now have the system of equations and its graph. And what do they want? They want us to have the solution of the system. Well, that just requires that we read the graph. That's not too bad. So I'm going to be x is equal to 4, it looks like. And my y appears to be halfway between 0 and -2. So maybe I should blow that up a little bit. You can see how it's halfway there. Of course, I pushed the thing out of the screen. So I'm going to say -1. All right. In the boxes below, indicate whether it is, what is this here? Whether the letter A or B to match the equation to the graph shown. Okay, so what does that mean? I guess they're going to want us to, okay. All right. Which one of these is 4x plus 2y equals 14, and which one of these is -4x minus y equals 15? Looking at this and trying to decide what to do, my selection would be to take this one and rewrite it. Okay, so I'm going to rewrite that second equation here to see which one this is. And I'm going to follow the thing that we did before again, which is that it's currently in standard form. Okay, minus y equals -15, and rewrite it so that it becomes slope-intercept form. That requires the y be positive and alone. So I'm going to, normally I would bring the y over to make it positive or bring the -15 over, but I'm going to leave it this way. I'm going to leave the negative y here. I'm going to add 4x to both sides. Add 4x to both sides, which is going to give me a positive 4x minus 15. But you still have to deal with that negative sign. So I'm going to multiply the entire thing, or divide the entire thing by -1. Another way to think of it is just simply reverse everything in sign. You would end up with a positive y, a -4x, and a positive 15. Okay, a couple of clues from this. This has got a negative slope. Well, they both have negative slopes, but this one has a y-intercept of 15, and that would appear to be the blue one. Okay, so it looks like this one is the blue graph. All right, so keep that in mind. So I'm going to mark this one with B because that appears to be the blue graph, and by system of elimination, process of elimination, it looks like this is going to be the other one. Okay, and submit. All right, and we did get that right. You're not seeing it because I backed up a little bit, but you can see that we got that question right. So again, tricky, makes you think, but not ultimately insurmountable because you've done these kind of problems before. All right, let's do number 2, whatever number 2 is. And remember, there's only 2 of these that we have to solve here. Let me click out of this. Did it work? I think it did, yeah. Okay, next question. Okay, now we have the dreaded fraction. Okay, now had we had to do this algebraically, this might have posed a problem for us, but because they're asking us to graph it, it really isn't that hard to do, I guess. We just have to graph these. So let's start with the first one, y equals 2x plus 3. Remember I told you, whenever you have this kind of a problem, you want to start with the 3, which is the y-intercept, and you want to follow the path of the slope, which is 2 over 1. So knowing that to be true, I'm going to start with 3. And did I click the thing on the bottom? I guess I didn't. Let me go back down there. Let me grab that bad boy. I'm just trying to pull it down. Okay, I need to click on this. Okay, we're ready to graph. So it's positive 3 for my y-intercept, and I'm going to go up by 2 and over by 1. Okay. Now I have to do the same thing for the other equation, and that one's a really deliberate fraction, if you see what I'm looking at there. So we're going to have to keep that in mind and not get intimidated by that, because again, we own this. This is going to have a y-intercept of -2 beginning down here, and this is going to go down by 1 and over by 2. So putting all that together, I'm going to click into my graph mode. I'm going to begin at -2. I'm going to go, let me try that one more time. I'm going to start at -2, okay, and then I go down by 1 and over by 2. Okay, that seems to be correct in both cases. So then the question finally is going to be, where did it intersect? Well, we can see that intersected here. And if we know how to read our graph, that's -2, -1. So that would be what we write down for our solution. It would be a -2, -1. So I'm going to see if I can pull this down here. Oh, I guess that's it. They don't. Oh, here. Okay. So they want us to do a -2, comma, -1. Don't forget to put it in parentheses because I know how Lumen gets by this time. And submit. And we got the green bar that we're so happy to see because that means that we got it right. So I think that's it for this particular video lesson. Yeah, we're finished. My next lesson will be what the homework looks like, or it's going to be what's the next step after graphing, and that's going to get algebraic. So be ready. Bring your calculator. Bring what you've done in the past with you, and I'll see you on that side too. Okay.